Hello, I'm Gwo Jen Hwang from National Taiwan University of Science and Technology. It is my great honor to give the talk titled Methods and Tools for Learning Behavior and Interactive Pattern Analysis. Learning analytics refers to using the data produced by learners to discover information and social connection in order to offer advice for learners. So there are three kinds of persons who will benefit by learning analytics. The first one is learners. They can receive advice from the learning systems or from the teachers based on analysis of their learning process. And also, teachers can benefit from learning analytics because if we know what happened to the student during the learning process, then teacher can make reflection on their teaching plan accordingly. Of course, educational policy maker can also be benefits from learning analytics because using those big data analysis, more suggestions can be provided to educational policy makers. So why learning analytics is so important in the field of e-learning researches? Because most of the e-learning study merely report the effectiveness or prove the effectiveness of the proposed system or the proposed strategy by using pre-test, post-test, and pre-questionnaire and post-questionnaire. Only few studies have tried to analyze student learning log or student interactive content during the learning process. If we can analyze student learning process, then more convincing evidence could be provided and to answer several questions that we cannot answer before. For example, we can answer the question, what happened during the learning process, or why the experiment group had a better learning outcome than the control group. What are the differences between the behavior pattern or interactive content or students with different personal characteristics, such as low and high achievers? We can compare their behavior pattern. Of course, we can provide in-depth interpretation of the finding. Not only just state that, okay, the two groups had significantly different learning achievement or different learning motivation. We can have in-depth interpretation by explaining why and what happened. Before we analyze student learning data, we need to define the coding scheme. What is a coding scheme? It is a set of codes that can transfer those behavior or interactive content which are ill-structured into unified and meaningful categories which are structured. For example, if a student play a digital game and he or she try to talk to NPC, that means non-personal character in the game, and then we might code the behavior into seeking help. That is one of the coding items. We call it seeking help. Also, during the digital game-based learning process, if the learner or the user go to the library in the game and read some supplementary materials, then we can code this behavior into another item, reading learning material. So based on this coding result, then we can make the learning data become unified and meaningful. Usually there are several data that need to be coded, such as interactive content or learning behavior recorded on video. In such kind of learning data, usually manual coding is required. And usually we need to code the data by two persons. And based on the coding scheme, for verifying the consistency of the coded result, we would like to see that if the coding result of these two persons have consistent degree more than 0.8, that means a capability bigger than 0.8, then we say, okay, that the coding result can be accepted. And then we use the coding result to do some further analysis. For example, this is the learning interactive content of a discussion forum. The students were asked to discuss something about global warming. And there are 5 students, A, B, C, D, E, in this discussion forum. Then A say, why is global warming important? And then B might say, okay, the temperature of the earth is rising. A then might say again, what does that have to do with us? This is the record of the interactive content in the discussion forum. So as we can see from this collect data that are ill-structured, so we cannot analyze such data without coding. Before we analyze this data, we need to be able to code them. That means we need to transfer those data into some well-structured items. So we can code the interactive content like this. For example, the first item, why is global warming important? We code it into an item that is raising a question. And the B say the temperature of the earth is rising. And then we code this sentence into providing an answer. That's what the student try to do. Then A say, what does they have to do with us? And then we code it into the same item, raising a question. And then C say, it is mainly because something like that. Then we say that C also try to providing an answer. And then D say, it seems to be because of something. We know that D is also providing another answer. And E say something, providing another answer. And then A raised another question. But the barbecue of the festival occurs only once in a year, so it do not have much effect. So A provided another opinion. This opinion is an objection because E say that it's because of barbecue, but A does not agree, so he raised an objection. And then B say, yes, I also think barbecue is not the main reason. So B agree with A, so B proposing an agreement with A. And then A say, a new barbecue restaurant opened near us. Very good. A lot of meat called meat duo. Then A say something irrelevant to the discussion content. Remember, our topic is global warming, so we code this item into irrelevant content. And then after A starts talking about some irrelevant content, then C also say, it is a hot-pot restaurant. This is also irrelevant content. As we can see that when someone proposes some irrelevant content, then others will follow this person and then give several irrelevant content. And then D say, it is very expensive. This is also irrelevant content. And then A then say, oh, the cost is about $299 for one person. This is also irrelevant content. And then E follow their discussion. So their discussion come to a situation that is irrelevant to the discussion topics. As we can see that there are several irrelevant content because of someone say something irrelevant. And then finally B say, shouldn't we think about problem of global warming? Is there some other reason? So B try to lead the discussion back to the main topics, and then he or she raises a question. So as we can see from this example, after we transfer or we code this data into well-organized items, then it will be easier to analyze the data because it becomes several consistent items, or we say unified items. This is the coding result. So what I'm trying to say is when we try to analyze the data, collect maybe from online discussion forum or from a game or from an online learning management system that records student behavior during the learning process, we need to code the data first. So it will help us to clearly see what happened during student learning process. Of course, in some learning system or in some digital game, the learning behavior or the coding item have already been embedded in the system or in the game. So in this status, then no manual coding process is required. We already store each student behavior into a unified set of coding items such as seek help, reading learning materials, accepting challenge, avoiding challenge, correctly answer a question, or fail to answer a question. If the system already recorded the behavior using predefined coding scheme, then no manual coding is needed. So of course there are other usages of developing a coding scheme. For example, if we want to evaluate the student higher order thinking performance, based on the data collected from the student's diary, student's report, or student feedback to some open-ended question, then we need a coding scheme to further evaluate the student higher order thinking performance. For example, if we want to evaluate student critical thinking by analyzing their interactive content or report, then how can we do that? The first thing we need to do is we define a coding scheme, and then we can use a rubrics based on the coding scheme to compute students' critical thinking scores. Here is an example. So we need to think about what are the features of students with critical thinking competence. And someone might say, if the students have high critical thinking competence, then they will have reasonable criticize during the learning process. Okay, they will raise some reasonable criticize, or they can make comparison on others' opinion. If several classmates or several peers have raised some answers, then the students are able to make comparison of the others' opinion. Also, they can provide in-depth opinion or inference during the learning process. Also, they can provide some simple opinion or simple evidence to support something. This is only an example. So if we consider that a student critical thinking competence need to have these 4 behavior, then we can organize a coding scheme. That means we can code students' interactive content or their behavior into those 4 categories. And then we can try to computing their critical thinking competence or score using some rubrics like this. As we can see that we have 4 dimensions. The first one is the number of reasonable criticize the student proposed. The second is the number of comparison he or she made. And the third is the number of in-depth opinion or influence the student behave. And the fourth is the number of simple opinion he or she provided. If we use a 5-level scoring scheme, then we say that for each dimension there could be 5 levels of score. That is 5, 4, 3, 2, 1. And we usually use the average number in the middle. That means if the student on average they propose 5 of reasonable criticize, then we use 3 or 4, 3 points. Okay, so we can put it here. And then if only few students have 8 reasonable criticize, then we say, okay, this could be give a 5 point. And if only some students have 1 reasonable criticize, then we say, okay, this is 1 point. Anyway, if we have this rubrics for critical thinking, then we can analyze students' interactive behavior or learning behavior and count how many times they have shown such behavior. Then we can count their score. In this rubrics, the perfect score is 20, right? Because we have 4 dimensions, and each dimension is scored from 5 to 1. There are also some well-defined coding schemes that can be adapted when we try to analyze student learning process. So in our research, we can adapt those already well-defined coding scheme. For example, this is a famous coding scheme called Interaction Analysis Model, IAM. It is proposed in 1997, and it is mainly used for online interaction analysis. So in this coding scheme, IAM, it consists of 5 phases to describe what happened during online interaction. And the first one is about sharing or comparing of information. And for example, it has 5 coding items in phase 1, and the coding item E of phase 1 is definition, description, or identification of a problem. And the second phase is about discovering and explaining the inconsistency among idea, concept, or statement. The third phase is about negotiation. And the fourth phase is about testing and the modification or construction. And finally, the fifth phase is agreement statement. It consists of 3 coding items. And usually, we did not adopt every item suggested by IAM. So when we do some learning analytics, we will use simplified coding item or coding scheme. For example, in this study proposed by Professor Hou Huizhe in 2008, and they only use 5 coding items selected from IAM. The first item, P1, is about propose, define, and clarify problem. And the second item, P2, is about providing solution or information for possible answer. And P3 is about compare, discuss, and analyze. And the fourth item is about organize and form conclusion. And the P5 is others. Others mean the discussion content that are irrelevant to the main theme of the discussion. So this is another example conducted by Tosti, Jiang, and his colleague in 2014. And they try to analyze students' interactive content in a discussion forum after they join an AR-based collaborative inquiry-based learning activity. They also adopt 5 coding items in their coding scheme. The first one is raising or defining a question. The second one is proposing a solution to the question or offering information relevant to the question. The third is comparing or discussing the solution proposed for the question. The fourth is reaching a conclusion regarding their discussion. The fifth is relevant content to the discussion topics. It is similar to the coding scheme adopted by Professor Hwang in the earlier study. So I would like to briefly introduce what happened in Zhang ETL study. They try to design an AR-based collaborative inquiry learning environment. So the students were situated in an encouraged area to learn to observe using AR-based mobile learning system. This slide shows the learning process of the student during the AR-based learning activity. And the students first were situated in real-world learning context to make observation of the plants on school campus. Then they need to collect data, they need to make observation, they need to answer the question raised by the teachers, and then they need to publish what they collect in an online discussion forum. They can also watch classmates' data so they can share their findings to each other. And after that, then they go to a discussion forum to discuss the topic raised by the teacher. So the data were collected by the learning systems, and then researchers try to analyze what happened during their learning process. There are two classes of students from an elementary school participated in this experiment. One class is the experimental group with 28 students, and the other class is control group with 29 students. So during the learning process, the experimental group learned with the AR-based mobile learning system, and the control group learned with the conventional mobile learning system. So one group with AR, the other group without AR. And this is the learning scenario of the two groups. In the left-hand side is the experimental group who learn with AR. In the right-hand side is the control group who learn with conventional mobile learning system. The researchers try to analyze students' interactive content collected from the data in the discussion forum. For example, one student say, while the leaf shape of this plant is flat and round, then this sentence is coded into P1, that is raising or defining a question. And the other student say, I think it is because the plant requires more water. Then this sentence is coded into a P2, that is proposing a solution to the question. And another student say, I think it is because the plant requires more sunshine. Then this statement is coded into P2 also, because the student also proposed a solution to the question. And then another student say, I think Tom's answer is better than John's. Then this sentence is categorized into P3, that is comparing or discussing the solution. So after doing that, we can build a frequency transition table for the two groups. As we can see in the left-hand side is the frequency transition table of the experimental group. But what is a frequency transition table? It is used to calculate how many times one behavior occurs after the other behavior. For example, from behavior P1 to P1, there are 488 times. So it's a frequently occurred behavior pattern from P1 to P1. If the student have P1 and then follow the P1 have P2, then from P1 to P2 is occurred 193 times. So as we can see, after we have these two tables, we compare the behavior pattern of the two groups. For example, from P3 to P3, what is P3? Making comparison, right? So the student in the experimental group keep making comparison after another comparison. So it main comparison and main comparison, it have occurred 103 times. However, the similar pattern only occurred one time for the control group. So this is quite significantly different between the two groups' behavior. And also we can see that from P4 to P1, P4 mean make a conclusion. After someone make a conclusion, then someone raise another question from P4 to P1. This pattern occurred in experimental group for 33 times, but it never happened in the control group. Follow that, we need to determine whether those patterns are significant. Then we need to calculate their least score. If the z-score is bigger than 1.96, then we can say that the sequential relationship is significant. So we mark those behavior patterns. For example, P1 to P1 is significant. P1 to P2 is also significant. Or P4 to P1 is also significant. Then we can draw a graph to show those significant relationships. These are the significant relationships of the two groups. As we can see, there are some difference between the two groups. For example, in the experimental group, there are a frequent occurred pattern that is P2 to P2, but it does not happen in a control group. So the experimental group student, if someone provides some answer, then the other provide another answer. They keep post different answer during the learning process. Also P3 to P3, P3 mean they compare answer from peers. So they will keep comparison and comparison and comparison several times. So this is a frequent occurred pattern for the experimental group. But there is no such pattern in the control group. This slide shows the frequent occurred behavior pattern only for the experimental group. So we can use this pattern to explain why the experimental group had better learning achievement than the control group. As you can see that P2 to P2, P3 to P3, and P2 to P4, P4 to P3, and P4 to P1. With this analysis result, we can interpret the experimental result or interpret the research outcome in depth. This is another study that tries to analyze student learning behavior in an English vocabulary learning game. It's a digital game. The author tried to compare the behavior of the student who learn with digital games in two different modes. The first mode is a Chrome-based test item, and the second mode is a multiple choice-based test item. In this study, the author adopted a pedagogical theory that is single and double loop learning theory. And what is single loop learning and what is double loop learning? A single loop learning indicates that some students fail to make progress during the learning process because they choose to learn in a single loop learning approach. That is, when they accept a learning task, they try to complete the task. But when they fail to complete the learning task, they try it again without acquire additional knowledge or without seeking help. They just keep using and maybe try and error strategy to complete the learning task. In such a strategy, the student seldom make progress after the learning. However, for those who learn with a double loop learning strategy, the student usually will accept a learning task and then try to complete the learning task. But when they failed to complete the learning task or they have encountered some problem, they will try to acquire additional knowledge or try to seek help from others, and then they come back to face the same task and then try to solve the problem again. And if they fail again, they try to acquire more knowledge and then they face the task again. So this is a double loop strategy. In this theory, it is emphasized that students generally make progress because of choosing the double loop learning strategy. That is, they try to acquire more knowledge when they have encountered some problem or when they fail to complete the learning task during the learning process. In this study, the author tried to show that single loop and double loop learning behavior exist during the game-based learning process. So they try to record students' learning logs in the digital game. So before doing that, they define a coding scheme like this. L means reading learning content, I mean reading gaming information, and A means accepting the gaming task, S means reject the gaming task, O means complete the learning task, and X means fail to complete the learning task, and G means look for gaming hint, H means look for learning help, and T means change the scenes, M means take the props in the game. This is the coding scheme, and each coding item is embedded in the digital game. So after students play the game, then we can know their gaming behavior during the learning process. An experiment was designed to collect data from the student, and the two classes of students were recruited to join the experiment. One class is the Explore group, who learn with the game with Cron's guiding strategy. That means in the game, Cron test items were used. And in the other group, they learn with the game with the multiple choice guiding strategy. That means multiple choice items were adapted in the game. And then, of course, there are some pre-test, post-test, and pre-questionnaire, post-questionnaire in this experiment. But the most important thing is they also try to analyze the behavior pattern of the two groups. This is the behavior pattern of the student learning with the Cron guiding strategy. As we can see that this is a double loop learning, because when students failed, they will try to acquire more knowledge and then come back to face the challenge. If they fail again, they will come to read more learning content and then come back to accepting the task. And finally, they got success. This is a double loop learning. So they use this behavior pattern analysis result to explain why the Cron guiding strategy had better performance than those who learn with the multiple choice guiding strategy, because the Cron guiding strategy group has done with a double group learning strategy. And this is a behavior transition diagram of the group learning with the multiple choice guiding strategy. As we can see that when a student accept a task, and if they failed, they did not come back to read and then come back to accept challenge. They might read, but they never come back. So they just keep trying and error. They fail and then come back to attack the task, and then they try and come back and try and come back and until they success. So they use a trial and error strategy to complete the learning task. That is, they use a single loop learning strategy. So based on the comparison of the two groups' behavior pattern, the author explained that the students who learn with the Cron-based learning strategy have significantly better learning outcome than those learn with the multiple choice guiding strategy, because they use a double loop strategy rather than a single looped learning strategy. The author concludes that students learn with the Cron guiding strategy had reviewed the learning content after they failed to correctly answer the learning task. So they tend to learn in a double loop strategy. On the other hand, those learn with the multiple choice guiding strategy kept guessing the answer. I mean, they use a try and error strategy during the gaming process. They seldom review the learning contents again, so they tend to learn in a single loop strategy. So this is what the author explained after they have analyzed the behavior pattern of the two groups. So they suggest that in the future, where if we want to develop some learning system or some game-based learning system, and it is better to guide students to learn with the Cron-based strategy, and it is better to guide students to learn with a double loop learning approach. This is another example. In this study, the author tried to design a collaborative knowledge construction game. So the students were asked to play the game together, and then need to complete table to summarize what they have found in the game. And they have a discussion forum, so when during the gaming process, the same group of students can discuss what they have found during the game, and then they need to complete this table to summarize what they have found. Also, the author have defined a coding scheme for analyzing the students' behavior during the gaming process. For example, S1 means selection of a task, S2 means make observation, S3 means make comparison, S4 means reading material, S5 means search for clue, and S6 means correctly comparing learning target. And in this study, the author also designed a course experiment by recruiting two classes of students. One class learn with the digital game-based learning approach with those table construction tasks. And the other group only learn with the digital game without need to construct the table or the grid. They then analyze the behavior pattern of the two groups. These are the frequently occurred pattern only for the explorer group. That is the group who need to construct the table or the grid during the gaming process. As you can see that in the explorer group, they have more observation and observation after observation, and more comparison after comparison, and more searching for group after searching for group. So the author use this particular behavior pattern to explain why the explorer group had better learning achievement than the control group. These are the conclusions made by the author. They conclude that the explorer group had a better learning performance than the control group because they have more behavior pattern of comparison and observation. And also they try to seek clues when observing the learning target. Also they conclude that from the behavior pattern analysis, it seems that the explorer group would like to deal with the learning task on their own rather than seek help from the teacher or from others. And now I would like to tell you how to analyze the behavior sequential pattern. It consists of several steps. In the first step, we need to define the coding item. And following that, we need to design the experiment. Of course, we need to collect data, and then we collect data. And after that, we need to check if the coding item need to be added. Sometimes we might find some new behavior that is out of our expectation. And then if the behavior is very important, then we need to add the new item to the coding scheme. So we need to modify the coding scheme if necessary. Then we need to code the data. So as I have mentioned, sometimes we need to manually code it. And sometimes if we already embedded the coding item in a learning system we developed, then we don't need manual coding. And then we need to check the coded data if we do manual coding to test if the kappa value is greater than 0.8. And then we need to use a tool called the GSEQ to do the sequential pattern analysis. After that, the GSEQ will generate a frequency transition table and the adjusted residuals tables, that means Z-score table, and then we can draw our behavior transition diagram based on the Z-score table. Now I would like to briefly introduce this software GSEQ for analyzing sequential behavior pattern. Usually we download the GSEQ version 5.1. It can be used in Windows 95 or later version, such as Windows 10 or in Windows 11. And if you need more details, you can refer to these two papers. Also, there's a book about GSEQ. If you need even more detail about how to use GSEQ, you can read these books. Now I would like to introduce how to use GSEQ. First of all, you need to search for GSEQ from Google, and you can find this website, and then you can download the software. Usually, GSEQ store their data in two forms. One is SDS file and the other is MDS file. In the following, I would like to show you an example of how to use GSEQ to analyze the data you collect. I mean the already coded data. When you start GSEQ, you will see this interface. In the upper part is the toolbar, and in the lower part is the information window. It shows the result of the analysis. So we can start a new SDS file, and then we can copy paste the coded data. So in this part, we need to tell how many coding items included in this data set. For example, in this example, there are 5 coding items, A, B, C, D, E 5 coding items. And then we copy paste each student's behavior pattern. For example, for student number 1, this is A, and then B, and B, and then D, then B, and B, B, A. Okay, this is a sequential of the student recorded during the learning process, and then student number 2 and student number 3. As you can see, there are some keywords in GSEQ. Event means we start a new task for analyzing the behavior data. So, and in this $sign, behavior is used to define how many behavior are included. In this example, there are 5 behavior A, B, C, D, E. And this is data for individual student. For student number 1, then A and a space, okay, D space E space A. Okay, this is a sequence of what happened for student number 1 during the learning process. The data ended for this student, and we put a semicolon here. This is the end of the student's behavior, student 1's behavior. Okay, and here comes student number 2. If there are no further data, then we use a slash to show that this is the end of all of the data to be analyzed. And then we can save the SDS file. And then we need to compile this SDS file into a MDS file. And then we choose run to computer table stats. And when doing that, we need to define what are the behavior patterns we are interested in. Usually we will put the 5 item from the beginning behavior and the 5 item to the target behavior. So from 5 item to 5 item, and that means from all item to item. We need to know all of their relationships. And then we click join frequency, and then we click on this adjusted residue, and the system will immediately generate these 2 tables. This is the frequency table. That means from A to A, there are 23 times. From A to C, 33 times. And this score table. Okay, so as you can see that several patterns have this score bigger than 1.96. From A to A, from C to A, from B to B, from C to C, from B to D, and from E to E. There are 6 frequently occurred patterns. Then we can drop the frequency transition diagram based on the Z-score table. Okay, so this is the result. Of course, we can do this again in another group, and then we can compare the behavior pattern of the 2 groups. So of course, there are other tools for learning analytics. For example, there are several learning management systems that can provide a very detailed analysis result for student video watching behavior or learning behavior. Of course, there are data mining systems such as SQL server that can also do some mining on students' learning logs. Of course, we can also use statistic analysis systems such as SPSS to analyze students' behavior or frequency of their behavior pattern. And this is an example of a OneNote.net. OneNote.net is a learning management system for free classroom. So it provides very detailed analysis result on student video watching behavior. For example, we can, of course, it can summarize students' status of watching video or complete the learning task. But most importantly is it can summarize student status before the class. For example, there are 3 learning tasks in this week, and some students already completed 3 tasks, but some are not. And also it can analyze students' behavior pattern of watching the video. For example, this student, Mr. Wu, he watched the video again and then come back to watch this for the second time, and in the 1 minute and 6 second location he stopped, and then he go back and to watch for 13 seconds, and then he stopped, and then he keep watching for 35 seconds, and then stop, and then keep watching for 37 seconds and so on. Now, so the system can provide very detailed record for student video watching behavior. Okay, so based on this recording, we can code those behavior based on some coding scheme, and then we can analyze students' behavior and to explain why the student have better learning outcome than others or have worse learning outcome than others. And of course, this system also can let students submit their comment on the learning task. Of course, there are many different methods for doing learning analytics. And the time sequential analysis or behavior pattern analysis is only one of the method I introduced today particularly. Of course, we can also use some other methods such as decision tree, clustering association rule, or visualization technology, such as we can let the system generalize a statistical graph, okay, after analyze the data. Of course, there are many research issues of learning analytics. For example, we can propose a new approach of learning analytics and educational data mining. We can also investigate the impacts of the personalized support provided based on the mining result or based on the learning analytics result to see if the analyzed result do benefit the student. Okay. Of course, we can also make prediction regarding student learning performance based on the analysis result. And also we can investigate the potential application and the effectiveness of the visualization of educational data. And we can also analyze students' behavior pattern to explain their performance in comparing with other learning strategy. Also, we can compare the behavior pattern of the student with different personal factors, such as low and high achiever student, the student with different cognitive style or learning style. And we can also develop new models or assessment model based on learning analytics result. And we can also propose effective data integration, cleansing method, and the management tool for processing educational data. And we can also investigate the privacy and security management problem or issue for open educational data. This is my talk today. Thank you for your attention.